Hello, and welcome to this pretty quick practice set on graphing linear inequalities in two variables. As always, like and subscribe if you find this video helpful, drop a comment or question below, and check out some of the other playlists on the channel for further math help. Pause the video to work these problems on your own, and then come back to check your work. Okay, so these first ones are asking you to graph and use a test point to check. And it's not because that's the more efficient way. It's actually more efficient to not use a test point. But test points do become critical in other levels of math that you know that you can use test points and that you have some experience using them. So it's worth it, just as it's a little bit forward thinking. Now, this particular inequality is not in slope-intercept form. So you've got two options here. If you want to graph this, you can build a table and plot the points to find out where the line is, or you can convert it over into slope-intercept form. I'm going to build a table in this case just to have some variety in the practice set here, and later we're going to be using slope-intercept form. So I'll set up my table here. So we'll set up the x, y, and I'm going to go ahead and start with maybe x is equal to 0. Okay, so we're going to see what's going on there. And I'm actually going to convert that over to an equation. This is just for the purpose of graphing the line, okay, to find out where the placement of the line is, which is why I'm using the equal sign. I am aware that it is greater than. 2 times 0 is 0, leaving me with 3y, and then we'll divide both sides by 3 to get y is equal to 2. So when x is 0, y is 2. Now, picking another point becomes a little bit weird here because I can pick any value for x that I want, but I'd kind of like to pick something that would come out nicely. And so what I'm going to do is use the fact that I've done a ton of these to kind of figure out, let's see, that if I pick x is equal to 3, that is going to come out nicely. So I'm going to go ahead and pick x is equal to 3. And so we'll have 2 times 3 minus 3y is equal to 6. 2 times 3 is 6. And we're going to subtract 6 from both sides. So 6 minus 6 is 0, leaving me with 3y. 3y is equal to 0, divide both sides by 3, and we get y is equal to 0. So when x is 3, y is 0. Now, if you're wondering, like if you're looking at your work and saying, well, I ended up with some awful fractions here. What I did, so you know what I was doing, is when I wrote the problem, I know that 6 is divisible by both 3 and 2. And so I knew that if I plugged in a 0 for the x, that the 6 would divide nicely by the 3 and I would be okay. But I also knew that if I plugged in a 0 for the y and caused that to drop out, that the 6 would divide nicely by the 2. So in my head, I thought, okay, well, I basically solved it in my head. And said if this is 0, y is 0, then 2x equals 6, and 6 divided by 2 is 3, and then just said out loud, hey, x is equal to 3. But that's what I was doing. And that comes from, 35 years at this point, something give or take, of doing problems like this. Now, you can do that for a lot of inequalities or equations. You cannot do them for all of them. So you just want to be a little bit careful when it comes to, can I pick a y value instead? Like sometimes you can pick a y value instead. Other times it will not be worth it. All right, so back to our problem here. So with 0, 2 works, and 3, 0 also works. I do have an equal to for my symbol there, so I can use a solid line. Now, what happens a lot is students will just kind of automatically kind of go in this autopilot and will do a solid line and then realize after the fact, after they have done this like solid line, that it was supposed to be a dashed line. If that happens, just grab your eraser and just like make it dashed after the fact. That is a really common thing to do. And if you're afraid, if it's not clear enough, write your teacher a little note that says, this is a dashed line, just in case it's not clear. Now, for this one, we were asked to use a test point. And I mentioned in the video lesson, if the point 0, 0 is available to use that one. Zeros are really nice. So we're going to plug in x is 0, y is 0. So 2 times 0 plus 3 times 0 is greater than or equal to 6. Oh, I love zeros. 2 times 0 is 0, 3 times 0 is 0, and 0 plus 0 is 0. And I end up with 0 is greater than or equal to 6. That is not true. That is the false side of the line. And so that means this is the true side of the line, and we shade in the true side. Now, I mentioned in the lesson video, when you are doing these, make sure that your teacher is able to see 2 points on the line, okay? Don't make your teacher hunt for lines, even if you're using graph paper and a ruler and your line is beautiful and it's clearly in the right spot. Give your teacher some dots. Okay, it's just easier to see them. And when you're doing your shading, just make sure it's clear which side of the line that you're shading. Don't shade over the line and obscure where the line is. And once in a while, I will have students do this, where when they go to shade, they do something like that, okay, which technically is the right side of the line, but it also might be opening up for a misconception that maybe the student only thinks that that section of the coordinate plane. So you want to make sure that your shading is fairly widespread, but not like overlapping the line or anything. Okay, now the next one is already in slope-intercept form. So this is nice. This makes it a little bit easier for us to graph. We have a y-intercept of -5, which is right there, and a slope of 3. So remember, that would be 3 over 1. So we have our rise over our run. So from the y-intercept, we are counting up 1, 2, 3, and over 1. And this one is a dashed line. And this is what I meant when I said students will sometimes just go ahead and do like the solid line, and then they think, oh, it's supposed to be dashed. Now, this program won't let me do it, but you could grab your eraser and just make it dashed after the fact. Okay, if you're working in pen, that's not advisable. All right, so there's my dash line. And as I mentioned, if the point 0, 0 is available for you to check, use that. So we have 0 is less than 3 times 0 minus 5. 3 times 0 is 0. And 0 minus 5 is -5. So I end up with 0 is less than -5, which again is false. We're kind of having a pattern with that. That's false, which means the other side is true. And we're going to shade, and we're going to shade broadly, but we're not going to shade on top of the line so that the teacher cannot see what the line is, okay? So shade broadly, make sure that it's very clear that you understand that every single point on that side of the line is a solution, but don't obscure the line. Like, make sure that the person grading your work can still see where the line is and that it is a dashed line. Now, for these next two, we are asked to use slope-intercept form, and this one is not in slope-intercept form, so it might be debatable whether this is easier to do by putting it in slope-intercept form, or whether you should just like pick some points now that you know that you can pick points for X or Y, but we want to practice all the skills. So solving this for Y, we're going to add 3x to both sides. -3x plus 3x is 0, leaving me with -4y. Now, you might write 12 plus 3x, but since we're going to be graphing it, it might be more comfortable to write that as 3x plus 12. I would normally just write it as 3x plus 12. Now, when you go to do your division, don't forget to, 1, divide everything, okay? And because you are dividing by a negative, you do need to flip that inequality around. So -4 divided by -4 is +1. And that's what like triggers that flip, is we have changed the sign of that side. On the right-hand side, we'll have -3/4 x. That's going to be our slope. And then 12 divided by -4 is -3. Okay. And if you Need like a little bit of a refresher of what happened right there. That is 3x divided by -4. When you are dividing a positive by a negative, that is the same as if you divided a negative by a positive. That's going to give you the same thing. And then that is really -3/4 times x over 1, which could be written as -3/4 x. In other words, you can move that negative sign and you can kind of pull the x outside the fraction. And those are the like little things that have to do with, do you know how sign numbers work? Or are you comfortable working with fractions? That sometimes I'll do and then realize that I have lost some of my students along the way. So now we have our function I shouldn't probably use the word function. We haven't really talked about that. We have our line in slope-intercept form. We know that the y-intercept is -3 and the slope is -3/4. So I'm going to count down 1, 2, 3, and then over 1, 2, 3, 4. And this is a dashed line here. So we're going to make sure that we have a dashed line. Sorry about that. I had to turn my hand on the tablet here to write that. All right, and for this one, we are using the less than greater than to shade it. We're not going to use a test point. And we know that on the y-axis, if y has to be greater than, that my greater than numbers are going up, my less than numbers are going down. So this is y is greater than, so we are going to shade the greater than side. We're going to shade above the line. And last but not least, in our problem set, we have y is greater than or equal to -2x plus 3. So this one should not require any work on your part at all. So we have the y-intercept is 3. We have the slope is -2. So we're going to count down 2 and right 1. This will be a solid line. And once again, it is greater than, so we're going to shade the side with the greater than numbers. And that's literally all you need to show for that. That one can be done without any work. Of course, you can show some work. So if it helps you to write down that the y-intercept is 3, or if it helps you to see that the slope is -2 over 1, and that you want to make it clear which way are you counting. If you want to circle this and say that means I have a solid line, if you want to circle that and say that means I shade above the line, you are welcome to do that to make your work clearer. And of course, always follow what your teacher says that they want to see in terms of your work. But it is possible to do that without showing any work. Well, that's it. Don't forget, please like and subscribe if you found this video helpful. Engage by dropping a comment and check out the other playlists. We have some playlists on Desmos. We have some playlists on multiple choice questions and some other topics. Building an Algebra 2 playlist as well. So we've got some other playlists out there. Check that out, and I will see you in the next video.